Hello everyone, welcome back. In today's presentation, we're going to talk about concurrent statements in VHDL. It is often talked about in contrast with sequential statements. Concurrent statements are statements that are executed when driven by an event. The events are changes on signals associated with those statements. Think of, for example, input signals into logic gates that will trigger the change in possibly the output value of that. Sequential statements, in contrast, are executed only when encountered by the procedural flow of control. The actual order, the sequence in which they appear inside your VHDL code matters, because that's the order in which they will be executed. More like what you would think of in terms of traditional programming languages like C, C++. Concurrency is something that is especially characteristic to VHDL or generally to hardware description languages. The best way to emphasize that better is to actually look at some examples. And here is a very simple example. We've seen this before. It's the 1-bit full adder that has just two simple signal assignments, which are concurrent statements. When these two statements will be synthesized, implemented in hardware, they will be possibly translated into logic gates as shown on this side of the slide here. And concurrency means hardware parallelism. Basically, this logic gates existing in reality in silicon will be working in parallel concurrently, all at the same time. They will produce their outputs based on how the inputs change accordingly. So concurrency means, from a VHDL coding perspective, that the order in which we write these statements inside our architecture description here doesn't really matter. If we shuffle these two statements, this description would be exactly the same thing of exactly the same hardware. Imagine swapping this gate with the other ones somewhere placed inside an FPGA. They will be doing exactly the same thing in parallel concurrently. So that's another important aspect to remember or keep in mind when talking about concurrent statements. From at least the point of view of coding and writing that, the order in which they are listed here doesn't really matter. Here is a list of somewhat more complete examples of concurrent statements. We've seen already signal assignments, component instantiations, think of port mapping, processes, and some others that we'll see later on. Some more examples are shown on this slide. If you recall, the 4-bit adder we've seen before instantiates 4 simple 1-bit full adders using this port map. Right, all of these 4 different port mappings are concurrent statements. The order in which they would be written here doesn't really matter. If we shuffle list all of these 4 in any order we want, they will be describing exactly the same thing. This is a very simple signal assignment that assigns a hard-coded 0 to that signal. Recall also the edge detection circuit shown on the right hand side of this slide, which we had to describe using the so-called two-process coding style. We have to process. Processes themselves are concurrent statements. So if we shuffle these two inside this architecture description, that would be exactly the same thing. However, what's inside each of these processes are sequential statements. That is, the order, the sequence in which they are written matters, because that is the order in which they will be executed. So remember, what's inside processes themselves is always sequential statements. Processes themselves are concurrent statements. Port mappings are concurrent statements. Regular single assignments are concurrent statements, and you should think of them or keep in the back burner that the order in which they are listed, written as VHDL code, doesn't really matter. So in conclusion, concurrent statements execute in a concurrent fashion. Think of hardware parallelism, especially. In contrast, sequential statements are used only inside statements, inside the processes, and the order in which they are written matters. That sequence. That is pretty much it, and I'll see you next time.